Hello students, in this video let's see the next topic, that is rotation of object x about an arbitrary line. Okay. Suppose the question is asked, rotation of an object x about a line which passes through a x naught, y naught, z naught and direction cosines of line are cx, cy, cz. Write an algorithm for rotation about an arbitrary axis in space. Or the same thing can be asked as, write an algorithm for rotation through angle delta about a line passing through the point x naught, y naught, z naught and having direction cosines cx, cy, cz. Okay, so now let's write the solution of it. Consider given line passes through a point A, x naught, y naught, z naught, right? Fine. Now, first of all, step 1, translate this point A to origin. This point A to origin, so that line passes through the origin. Line will passes through the origin using, what was the transformation matrix for that? The transformation matrix is translation matrix, and that matrix is what? Minus x naught, minus y naught, minus z naught, 1. This one we have to translate to origin, so that the line will pass through origin. Okay. Now here, along with line, object is also translated. along with the line object is also translated. Right? Now how does the situation? Let me tell you. Suppose here this is x-axis, suppose y-axis and z-axis. Suppose somewhere here the line, here the point A having coordinates x0, y0, z0, right? Here the object x is there. This is an object x, and that one we have to rotate about this line through an angle delta, that is given in the question, right? So that object will come to this side, right? Due to rotation, that object will come in anti-clockwise direction. We are rotating, so rotation will give us, this is x star. Suppose this thing we want. Here the point A is that one. This is a line L. Okay, here the point A. Now I want to translate this point to whom? Origin. So translation we have did, so that the line will pass through whom? Origin. Okay, so when it will pass through origin, the figure will be as such. It will pass through origin. Okay. The point A will coincide with origin. O is nothing but A. That point will shifted here, right? So suppose here the point P having the coordinates Cx, Cy, Cz are what? The direction cosines of that line, right? Now if this, what is distance OP then? Origin having coordinate 0, 0, 0. So here this OP, distance OP is what? Under root Cx minus 0 square plus Cy minus 0 square plus Cz minus 0 square, right? Okay, so this is root Cx square plus Cy square plus Cz square, and that is equal to what? Root 1, because the sum of squares of direction cosines is what? 1. So this distance OP is how much? 1 we get, right? Here suppose this is x, y and z axis. Fine. This is our new position. Fine. Now after taking it to the origin, I want to coincide this line with z axis. I have to make this line coincident with z axis, and that can be possible by 2 rotations. Now 2 successive rotations we have to do. Now how does it? Let me explain to you. Now look at here. This is my 2-dimensional system. Suppose this is x-axis, y-axis, okay? And here let it be, this is z-axis. So here the 3D original plane will form. Fine. Look at, this is positive x-axis, this is positive z-axis, negative z-axis. Similarly x-axis, this is y-axis. Okay, now I have to rotate an object. Now basically it is in suppose I will take it in positive octant, and I have to rotate it to make it coincident with whom? With Z axis. Now look at here. I am just taking one octant here. This is x axis, y axis and z axis, suppose. Now here this is an object. Suppose this is our object. This one we have to rotate or make it coincident with whom? Z axis. So for that, first of all, I need to rotate so that it will come on this plane. This is what? This is x axis, this is z axis. So by first of all, it is as such. Try to understand. It is as such, right? This one will be as such. So here this one I will take here first and then I will take it as such. Okay. So wait. Hope you are getting this. Look at this is an object. This one. Yeah. These are our coordinate axes. So here first of all rotate it through x axis. Then it will come on xz plane. And then rotate through this y. Then it will coincide with whom? Z axis. So while rotating it through x, I will that angle is denoted as alpha, and here rotation about y axis through an angle, suppose that will be beta, then it will coincide with z axis. Now our aim here to determine those angles. So let's see how does we can determine those angles. So to determine those angles, I have to take a projection of this point P on YZ plane. When I will take a projection of point P on YZ plane, that point will be, suppose here the projection occurs, suppose the point having coordinates, if it is on YZ plane, then x coordinate becomes 0, this is CY, CZ. This is a point P. Suppose it is a projection of it. Projection is nothing but a shadow, you can say, and I had projected it there. So if this is a projection, then what happened? Due to that, look at here, this point P, if I will take its projection on this XY plane, suppose this is our projection of this point, okay. Now here if you see this distance is nothing but what? CX. The same distance will be here also, CX, right? Now again what happened here? Look at this. When I project it on this is what? CZ, and this distance is how much? This distance, sorry, here it will be as such. Wait, I'll draw another figure. Look at here. Here this is our OP1. Here we have been projected it on YZ plane, so x coordinate becomes 0. So due to that, this much distance is how much? CZ. This is what? CY. And when we project this point P on XY plane, this is what? CX. This is equivalent to this one, right? Now, you know OP is what? 1. Now let me name this distance OP dash will be D. As I taught you, that angle alpha is nothing but this one. When we rotate it through x axis, that angle will be this one. The same angle will be this one, okay. When you if you want, you do your on your own, then you will get this is an angle alpha here. Now our aim to determine the value of alpha, but to determine the value of alpha, first of all we need to determine D. What is D? Here this is CZ, the same one is this one also, this is also CZ. So if you look here, it will be a right angle triangle. So D is how much? What is D here? D is under root cy square plus cz square using Pythagoras. So D will be this one. Fine. Now angle P dash OM is how much? Alpha. So now once we have these values, we can easily write what is sine alpha. Sine alpha will be cy upon what? D. Sine alpha is cy upon D. And cos alpha. What about cos alpha? Cos alpha is cz upon D. So we have the value of sine alpha and cos alpha. Then we can easily get tan alpha. And from tan alpha we can get alpha also. Right? So also for the rotation we need the matrix of rotation we need the values sin alpha and cos alpha itself. So we can directly write down these values in that matrix also, right? So if we have to require alpha, then obtain tan alpha by taking this ratio sin alpha upon cos alpha, that is cy upon cz we get, and then get the value of alpha, that is alpha equal to what? Tan inverse of cy upon cz. You can obtain this one as such. Now let me write step 2 in detail. Till translation we get step 1. Now after that this whole part we will come in step 2. So let me write that thing in detail. Step 2, we make this rotation, or we make this line coincident with z-axis. Coincident with z-axis by using two successive rotations. So rotation about x-axis through an angle alpha, followed by rotation about y-axis through an angle beta. Okay. So now the first thing, to find alpha. As we have did it. Now that part is just for your understanding. Now here I will repeat that thing for just I had been explained there those things. So to here, if we have to write an algorithm, then we will write it as such. This is P, right? This is point P. Here this is what? CZ. P dash is what? 0 CY CZ. This is M. This is CY, right? This distance is 1. And this one we have been named as D. This is also CZ here. And this angle is what? Alpha. Okay. Now here consider line passing through origin with direction cosines Cx, Cy, Cz. Let P be point on line OP with length of OP is how much? We have been found it. It is how much? 1. Right? Therefore, P having coordinates Cx, Cy, Cz. We rotate this vector OP about x-axis through angle alpha. To find alpha, we take projection of point P. Projection of point P on YZ plane to get P dash is what? 0 Cy Cz, right? Therefore, angle P dash OM is how much? It is alpha. OP dash is how much? D. That is projected length. Therefore, this D is what? Under root Cy square plus Cz square. Okay. Also, what is sin alpha? It is Cy upon D. And cos alpha, it is Cz upon D. Therefore, we observe that the corresponding rotation is positive. It is in anti-clockwise direction, so it is positive. Three-dimensional rotation. It is positive three-dimensional rotation. Therefore, the matrix of rotation here, what is the matrix of rotation? Is what? 1, 0, 0, 0, 0, cos alpha, sin alpha, 0, 0, minus sin alpha, cos alpha, 0, 0, 0, 0, 1. And that is nothing but 1, 0, 0, 0. Here 0, cos alpha is how much? Cz upon D. So Cz upon D. This is Cy upon D. 0, 0, minus Cy upon D. And this is Cz upon D. 0, 0, 0, 0, 1. This one. Okay. Now, next thing we have to find beta. To find beta, that is rotation through y-axis, the next rotation, so that it coincides with z-axis. So for that one, how does it will occur? When it will come on this yz plane, right? Sorry, xz plane, not on yz plane, it is on xz plane. Point P will come here. So in xz plane, this x coordinate is same. But what about the z coordinate? Z coordinate will become D. That D will come here, right? So here this is Z, X and Y. So due to that, when we project it on x-axis, this distance is D. And this distance is how much? When we project it, this distance is how much? X. here. So what is this hypotenuse? Check this. This is also what? Cx. This is also what? D. So now you know D is what? This under root cy square cz square. So now when we obtain this OP here on in xz plane, if you get, this is nothing but how much of length? 1. And here we have to rotate this as such through an angle what? Beta, so that it coincides with z-axis. Now this is clockwise rotation, so it is what? Negative rotation. Okay, so now how does we find out it? Let's see. Now consider vector OP, we rotate it about y-axis through an angle beta, so that it becomes coincident with z-axis. So that it becomes coincident with z-axis, right? So now for that, let's determine cos of beta. What about cos of beta? Cos of beta is nothing but how much? D. And sine of beta? Sine beta is what? Cx. But we observe that this is negative 3-dimensional rotation. Negative 3-dimensional rotation. Therefore, beta must be replaced by minus beta. Beta must be replaced by minus beta. Now what is the matrix of transformation here? So that matrix of transformation, that is rotation through y, is what? Cos of minus beta 0 minus sine of minus beta 0 0 1 0 0. Here sine of minus beta 0 cos of minus beta 0 0 0 0 1, and that is nothing but, now you know cos of minus beta is cos beta, and that is nothing but d here. 0 minus sine of minus beta, so that will become plus, so it will be cx. Here 0, then again 0 1 0 0 as it is. Now this will become minus sine of minus beta, so minus cx 0, this is again d, it is positive always. 0 0 0 0 1. Okay, so this is a matrix for rotation through y-axis. As such, we have to find alpha and beta and then do this successive rotation so that it coincides with z-axis. When it coincides with z-axis, we can rotate the object about z-axis through the given angle, that delta is angle given to us. Okay, now so after using that rotation through z-axis through the given angle, later on we take back this line to its original position by using to take it again to original position. First of all, we have to use the inverse rotation through y-axis, then inverse rotation through x-axis, as well as the inverse translation. So let me write those things in short. Step 3. Now line is coincident with z-axis. Therefore, we rotate the object about z-axis through the given angle delta. Therefore, what is that rotation through z? That will be cos of delta, sin of delta, 0, 0, minus sin delta, cos delta, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Okay. We take the line back to its original position by inverse rotations, that is inverse rotation through y-axis, through x-axis, and then translation. Therefore, concatenated transformation matrix is what does that? T is what? Translation, then rotation through x-axis through an angle alpha, rotation through y-axis through an angle beta, right? Then original rotation, that is through an angle delta, then inverse rotation through x-axis, inverse rotation through y-axis first, then inverse rotation through x-axis, and then inverse translation at last. So this is first, then this one, and then this one. Fine. And step 4, therefore, what is x star? We get the transformed object, that is about x into t. As such, the object is rotated through an arbitrary line. Line is not parallel to coordinate axis, while it is any arbitrary line. Only a point on that line and its direction cosines are given to us. Now, here we will stop for this video. In next video, we will see examples on it. Thank you.